Hello. Sorry for that. So about myself, I got close to 12 years of experience. I worked on multiple functional programming languages, distributed systems, microservice architecture, DevOps, data engineering, front end, pretty much everything. So moving on. So today we would be discussing about what are the factors which contribute to latency, right? And how did we manage to improve our API response time? And how did Aerospike help us? So we would be going through the Aerospike in detail. So we would be talking about the distributed architecture of the Aerospike, the data model, what all are the query patterns, and how did we use those query patterns to optimize our APIs. We'll talk about hybrid memory architecture, which is a very unique to Aerospike. And then we would be going through some of the benchmarks and other use cases for Aerospike database. Okay. So maybe let's talk about a sample use case, which is a customer 360 platform here, right? So this example is very specific to a retail bank, but this can apply to any domain, right? For example, you can apply this to a retail domain as well. So you would see that many times information is distributed into different source systems, right? For example, customer information is very fragmented. So home loan, mutual fund, car loan, cards, Forex, each of these source systems would have some information about customers, right? Which is very fragmented. So there is no full 360-degree view of the customer, which you can get, right? And that is a very common problem which is faced by most of the organizations, because you need that kind of a profile to serve certain use cases, right? So then basically you can use some connectors to get the data into a centralized systems, right? So the data ingestion happens. You do some data quality checks, deduplication, enrichment, right? After all of that, once you have got data in a centralized system, you can serve that data to all the other services or products which are trying to use that information, right? So on the right hand side, you can see there are multiple channels or services which would be consuming this customer 360 profile. And it is extremely important to serve it in low latency, right? Because pretty much each and every other system in the organization is going to need that customer 360 profile. So it makes very important to build your APIs very fast and scalable so that they can scale to the volumes, right? So this is about our use case, some of the goals which we had defined when we started building this. So we wanted to build a system, customer 360 platform, where the API response time would be consistent and it would be less than 50 milliseconds, right? In terms of scalability, as of now, we were looking at 120 requests per second, and this was going to grow. We also wanted an API which would be able to support various search attributes and also combination of attributes. This is important to know because your choice of database can also depend on these requirements. If your database is not able to cater to some of these requirements, then it's of no use, right? So understanding these things beforehand is also extremely important while choosing a database. And it should be flexible enough to allow clients to choose information to be retrieved, right? Because customer 360 profile can have a lot of information and not each and every system is interested in all the information. So we also wanted to provide some flexibility there, right? And of course, the API should scale to the growing volumes of the data. These are some of the stats we had. or we have. So we do have 90 million plus records in production, right? Also in terms of volume, we are receiving 2.3 million records per month in terms of requests. Sorry, in terms of new data which is coming per month. In terms of requests, we are getting 10 million plus requests per day, right? The overall data size is around 270 plus GB, and each and every entity contains 250 plus attributes. This is again another important factor to understand when you are choosing a database, and we'll see why. So when it comes to looking at what all factors to contribute to the latency, right? So some of the factors which you can see here are DNS resolution, TLS handshake, network latency, which are very common, and most of the times you can't do much about it, right? What you can do is basically you can do some performance benchmarks on maybe DNS lookups, try to optimize, set up new DNS servers. Network latency, of course, you can set up dedicated links, and that's how you would be able to handle that. TLS handshakes, again, you can't do much about it. It should happen. But maybe you can use newer versions of TLS like TLS 1.3, which are pretty faster. It reduces a lot of round trips, right? In our case, we didn't use TLS 1.3 because it is still new and not all the clients would be able to support that. But the major two things you see on the right are compute and IO, right? Which do contribute the most to the latency. And more than compute, I would say IO is the most is the factor which contributes the most when it comes to the API responses, right? So I'll briefly talk about how did we improve the response time? How did we handle some of these latency factors? And then we'll do a deep dive on Aerospike. So for IO related piece, we ended up using a distributed NoSQL database called as Aerospike. It's a low latency database and it provides high throughput. And then we also use Micronaut framework as a framework for our API. How did it help us? So Micronaut framework basically it provides ahead of time compilation, meaning there is a lot less overhead at the runtime compared to other frameworks like Spring Boot, right? So Spring Boot and all, it takes a lot of time to scan the beans, and all of this happens at the runtime, which also ends up utilizing a lot of memory, right? If you see the footprint of a Spring Boot application versus a Micronaut application, you would see the difference. So we were able to start a Micronaut application in like 250 MB kind of a memory, right? Whereas for Spring Boot, it takes up to 1 gigs. So that benefit that was the benefit we got with ahead of time compilation, right? Also, it doesn't use any reflection and runtime proxies. That is another beauty of Micronaut, right? So no reflection means no overhead at runtime, which is very common with other frameworks like Spring Boot, right? Even for JSON serialization and deserialization, Micronaut handles it little differently. It will not use reflection for that, right? It uses something called as bin introspection. So it will introspect the beans at the compile time. It will keep all the information handy so that there is no overhead at the runtime. It exactly knows how to serialize your beans even before your application is bootstrapped, right? So we were able to save on those as well because of Micronaut, serialization, deserialization, overhead of runtime proxies. All those benefits did come with Micronaut, right? And like I said, less memory footprint and startup time. So in a way, now how you would say, how does it help in reducing the latency, right? But in a way, it contributes to reducing the latency, right? It definitely helps in scaling your application with less amount of hardware, meaning you can spin up more pods on the same amount of hardware if you compare it with other frameworks, right? Also, since you are not using some of these things like runtime proxies and all, your overall latencies of the APIs are pretty less compared to Spring Boot. There are benchmarks around that. Moving on, we also did use a lot of concurrency because we wanted to fetch data, and it was not like 1 or 2 calls per request, right? It was multiple calls per request which we were doing. So doing this kind of a IO operation in sequence, it's not going to scale, right? It's definitely going to increase your API response time. So we ended up using a lot of concurrency. The whole code base is full of Java futures, sorry. And the next thing, we had to do a JVM tuning as well. So by default, we were using Java 17. It comes with ZGC. But as soon as we did a performance test, soon we realized that ZGC is not suitable for low latency kind of applications. Whereas there is a support for ZGC in newer versions of JDKs. So we decided to give it a try. ZGC works beautifully for low latency kind of applications, whereas G1GC, it will work good for your other applications which are kind of batch in nature, because it will keep on piling up a lot of objects in heap and it will do a big bang GC. With ZGC, it is little different. It will do short cycles of GC, which also means we were able to get the consistent response time. That was another important factor for us. So getting faster response time is important, but getting consistent and faster response time is also very important. So with ZGC, we were able to do that, and we had to do a lot of heap tuning for that. Using appropriate heap size is also very important. Given the data volume and the nature of the data, you'll have to understand what is the size of the record, each record you are trying to return, right? And what is the volume you are trying to cater, and based on that, you will have to tune the garbage collector. We also used horizontal pod auto scaling, right? The reason to do this is many times what happens is once the heap starts reaching towards 90% of the utilization, the performance degrades exponentially, right? Because then there is a lot of GC overhead which JVM has to take. So horizontal pod auto scaling also made sure that whenever there are spikes, we are spinning up new pods, which means the performance is staying constant and consistent. There will not be any spikes in the response. Reduce network hops is another thing we did. So we had to take decisions like not using API gateways which are at the enterprise level, right? Because that means your request and response is going through one more network hop, right? So we decided to take these decisions and went against whatever was the common norm in the organization. So we didn't use any API gateways. So all the communication with our APIs is point to point. That did definitely help in reducing some of the network latency. And the most important thing is design patterns. A lot depends on what kind of design patterns you are going to use. It also includes query patterns, which is more important because everything depends on the IO. And if you end up using wrong design patterns when it comes to IO, it can impact your response time. And these design patterns were established way early when we began the project. And each and every decision would revolve around performance, right? So we used to have a lot of discussions, and then we used to decide what kind of a pattern we want to use. And most of the times it would be taken because of the performance, right? Even if it means compromising on some other things like readability or maintainability, we took that decision, and it definitely helped us. So today's talk is going to be focused more on the Aerospike, right? So Aerospike is a distributed NoSQL database. It provides speed, strong consistency, unlike databases like Redis, which is not strongly consistent. Even though it's a distributed, recently it has become a distributed database. Earlier it wasn't. It's not a strong, it doesn't provide you a strong consistency. Even Cassandra didn't use to provide strong consistency. I mean, when I say strong consistency, it is proven by some tests, right? So there is a test called as Jepson test. Typically, they would evaluate all these databases, whoever is claiming to have a strong consistency with different scenarios, right? So Aerospike is the database which passes that test. It's highly reliable. We'll see how it is highly reliable. It is able to survive node failures. It does auto balancing of the cluster. Can perform millions of transactions per seconds. It is extremely fast and it can cater to huge volumes, right? And predictable performance from gigabyte to petabyte kind of a volume of the data. So it provides consistent IO irrespective of the size of the data, which is very unique to Aerospike compared to other databases like Cassandra. It starts struggling when your data volumes start going up, right? Whereas Aerospike gives you predictable performance. Moving on. So this is the architecture, distributed architecture of the Aerospike, right? So like any other distributed database, there would be multiple nodes in a cluster, and these multiple nodes form a cluster, right? The database, the data is distributed over all these nodes, and it is equally distributed, right? It is balanced compared to other databases. All these nodes do communicate over a backend called as Fabric. So meaning all the replication, heartbeat communication, everything happens over the Fabric. And the about two boxes you see there, application. These are basically client applications which contain Aerospike clients, right? Aerospike clients are nothing but a library. It's not a physical component as such, which stays in your application, and it polls the Aerospike cluster and gets the information about the cluster, like how many nodes are active, which all nodes are live, and it also gets partition map. And we'll see how that partition map helps the client to reach the data in one single IO hop, which is again very unique to Aerospike, right? Um, Also, it is a shared nothing architecture, meaning each and every node has got its own disk, own memory, own CPU. Meaning in the cases of node failure, you are guaranteed that only one node is going to go down, right? It doesn't share anything. All the nodes are equal, meaning there is no master slave setup here, right? The request can be served by any node. So moving on, if you look at the smart client, there is a reason it is called as smart. It basically ends the cluster every 1 second, and it gets the information about all the nodes, right? Um, Typically implemented as jar, DLL, or a library in multiple languages. You can see what all languages are supported. It contains two parts. One is the API, which is used to query the database, basically CRUD operations or any other operations like creating or managing indexes. And it also has got a first-class observer of the cluster, right? Which monitors the cluster continuously. It knows when a new node is added or a node gets terminated or fails, right? And it also knows the partition map for each node. So we'll see about partition map in coming few slides. So first of all, let's maybe look at the data model of the Aerospike database, right? It's essentially a key value database, just like any other key value database. So Couchbase is also another example of a key value database, right? Or Redis is another key value database, where the data is stored as a key and a value. So when it comes to the Aerospike, the data is stored as records, right? One single data entry is called as a record, which is combination of a primary key and the data. So data is basically, again, it is nothing but it's called as bins in Aerospike, which store bins, BINS, which stores name and value, right? So name of the bin and value of the bin is stored along together in the record, which also means there is no schema present at set level, right? The schema is defined at a record level. So each record can have its own schema. As you can see in the diagram, the record where primary key is 1, the schema is little different than the other ones, right? Which is possible with such kind of a key value storage. And we also leverage this to gain performance benefits, right? We were able to combine multiple tables into one because you would be able to save or store heterogeneous data in one single set and be able to query it, right? So instead of now querying 5 different tables or 2 different sets, you can query one, so which essentially saves you a IO operation. So we also leverage that. These are some of the data types which are supported. I'll not go into the details. So usual scalar data types, but it also supports list, map, and other special data types like hyper, log, and GeoJSON, right? So data types like list and map are very useful when it comes to storing data, to effectively query it or to effectively save it, right? And we'll also see some of those patterns. GeoJSON, you can use it to fire geo queries. Basically, the objects are stored as geogeometric objects. Can be useful in cases like, for example, uh, car or cab service where you want to figure out how many drivers are in a proximity, right? So those kind of queries are possible with GeoJSON. So those kind of data type supports are also there in Aerospike. The records are basically clubbed together logically into a namespace or a set. Sorry, not a namespace, set. So all the records, they can be clubbed together into a logical entity called as set. It's not a physical entity like how it is there in relational databases. It is just a logical one. You also have records without any set, meaning they would be saved in a default null kind of a set, right? So here you can see people is set, which will hold data related to people. Likewise, places is another set, right? And these sets can be present in a namespace. This is similar to table space in RDBMS. And each namespace can have its own storage engine. So we'll also see about different storage engines. But as you can see here, each namespace can have a different storage engine. It can have flash, DRAM, or persistent memory, right? And configurations like replication factor, what is the storage engine, memory size, write block size, all of that can be defined at a namespace level. So this is a comparison of some of these terminologies and their equivalents in RDBMS, right? So row is like record is like a row, bin is like a column, and set is like a table, namespace is like a table space. So let's look at the typical partitioning mechanism which is used by usual NoSQL databases. It's a very common pattern which is used, so you might be able to relate it like Cassandra and all. So here you can see it. There is a cluster of certain nodes, right? And whenever you want to store a data in a key value database, you have to provide a partitioning key, right? Most of the databases would ask you to define that partitioning key. You have to take that decision, what partitioning key you want to use. And if you end up using the wrong partition key, like in this case, if you use country as a partition key, right? So for countries like India, the data could be huge. So what it will do is it will take this partition key, it will create a hash of it, and it will store it in a node or a partition based on the hash, right? So what happens is if lot of data comes for the same country, which is very common, if your key you have chosen doesn't have a high cardinality, it is very common that your partition can become hot partitions, meaning it will receive most of the queries, right? So in this example, node B has become a hot node or a hot partition, and it is receiving 900 queries per second versus the other nodes could receive 10, 300, 120 based on how the distribution of the data is based on the key chosen, right? So that's about partitioning, and also the way it is queried is little different in usual NoSQL databases, right? For example, when you connect to a cluster or query a cluster, the query can land on any of these nodes. So typically the node where it lands is called as a coordinator node. And then the coordinator node will coordinate with other nodes to look for the data because data is distributed, right? So it has to look for exactly on which node the partition is present and then return it, right? So this is very simple example here. Many times it is optimized. Like in Cassandra, each and every node would have cross references as well, meaning it doesn't have to go via circle. It can directly jump to node C and node D. So in bigger clusters, still there would be a lot of hops. This is just a small example, but Cassandra clusters could be huge, right? So this has a problem, right? It needs to take multiple hops to reach the data. So how does Aerospike solve this problem? So Aerospike uses fixed number of partitions called as 4K partitions. So it uses 4096 partitions and distributes the data on these 4096 partitions in a balanced way, so that no partition is a hot partition, right? So how does it do that? So in Aerospike, you don't really have a choice to define a partitioning key, right? It's a key value data store. So what it does is it will take your key, which essentially has got the high cardinality because each and every primary key would have a different value, distinct value, right? So it has got a intrinsic high cardinality. It will take the primary key. Basically, it will take the key type, and the set name, and it will apply a hash function, which is a RIPE MD160. It is a deterministic hash function, and it will basically create 20 bytes of a primary key, 40 hex digit, right? Other databases like CouchDB and all, they use CRC32 hash algorithm. CouchDB also follows similar partitioning mechanism, by the way, right? So first 12 bits are partition key. So out of the 40 hex digit which are created by the hash function, first 3 hex digit form your partition key, right? So 1 hex digit is like 4 binary bits, which is 12 binary bits. So basically you get combinations up to 2 raised to 12, which is 4096. That is how it uses 4096 partitions. CouchDB or Couchbase, it uses 1024, I think, right? Similar mechanism. So, and also on the right hand side, you can see it's a partition map. So whenever a primary key is hashed and a partition number is calculated, it would be maintained in a partition map. And based on how many replicas are created for each data or partition, it will also maintain the replica nodes. So it exactly knows on which node the given partition is present, both master and replicas. So going ahead, we'll look at how the Aerospike does auto rebalancing, right? So let's say this is a cluster, 3-node cluster, Aerospike cluster. The partition 1 is present on A node. It's a master, and its replica is present on B node. Each node will have its own partition map based on the algorithm which we just saw on the previous slide. So each node will maintain its own partition map. So it exactly knows how many partitions it has got. So since Aerospike has fixed number of partitions, each node will have 4096 by 3 number of partitions, right? Um, so let's just say, and also this is a partition map which would be present on the client side. So like we saw earlier, the smart client, what it does is it will get these respective partition maps from each of the node, and it will create a full partition map based on the partition map which is provided by each node. So it exactly knows if I want to fetch a data from partition 1, which node to go to. So it doesn't need that coordinator node, or there are no multiple hops here. It's one single hop to the data. So let's just say a new node is added in the cluster, right? So how does balancing of the cluster happens automatically? So as soon as it determines there is a new node which is available in the cluster, within few milliseconds, it will rebalance the partitions. It will calculate now those 4096 partitions needs to be distributed in 4 nodes, meaning one node will have 1024 partitions, right? So it will start copying the partitions on the new node. And once it has done all copying all the partitions, it will also have its own partition map. Now, if you see the partition map of node A is also updated to have only 1024 nodes, and so on. Partition B will also be updated. Partition map of B would also be updated. Likewise for C as well. This is how the rebalancing of the cluster happens automatically, and there is no manual intervention needed. This basically also reduces a lot of operational needs and operational cost as well. So, and in the end, of course, the partition map in the client side will be updated because it is continuously polling the cluster. So let's look at a node failure scenario. Let's say you have got 3-node cluster, and for some reason, the node B is on fire, green fire for some reason. Okay. And it had partition 1, which is a replica, partition. It's not a master one. And it also has partition 1366, which is a primary or a master partition. So how does the Aerospike recover from this, right? It doesn't lose any data. So if node B goes down, it will sense that B node has gone down, meaning all the data which was present on B needs to be now balanced. How does it do it? So B node had a partition 1, which was a replica partition, right? So now node C will get that copy from from node A, because the master partition is already present there. Replica partition is missing, so it will create that partition on node C. Likewise, 1366 was the master partition which was present on node B, and its a replica is already present on on node 6, node C. So it will create a new master copy of it on node A, right? That is how the data is recovered, or the balancing of the data automatically happens, right? And if the node B comes up again, same activity happens. That's how the balancing of the cluster would happen, right? So before going ahead, maybe let's look at some of the storage devices. And I think it is very important for Aerospike, because Aerospike is built for the newer generations or newer ages of storage devices, right? So you can see there is hard disk, NVMe, Intel Optane or DRAM. You can relate how fast or slow it would be, right? There is a picture for reference here. So then you would be able to imagine how fast the Optane storage would be with respect to hard disk drive, right? Mechanical drives. So hard disk drives have higher capacity, but also has higher latency, right? And so on and so forth. So SSDs, NAND SSDs or flash storages, NVMEs, they would have lower latency in microseconds. They would be able to relatively store lesser size because they are expensive. DRAMs would have much low latency, right? Very fast, but they cannot hold a lot of data. So there is a limitation of how much data can stay in DRAMs. And of course, cache, CPU cache and all would have the fastest performance, right? So, like I said, Aerospike is built on hybrid memory architecture, right? When Aerospike was developed, unlike other databases, which were typically or traditionally developed on old generation of storage devices like HDDs, Aerospike was primarily built with keeping in mind flash storages, right? So that they could leverage the full potential of it. So what Aerospike does is it stores index purely in memory, meaning in DRAM, and it stores data in flash, right? Flash storage or NVMEs or SSDs, so that you get a predictable performance, because index lookups are now in DRAM, which are very predictable compared to if you store it on a flash drive, right? So, and Aerospike would also make sure that SSD wear is not uneven, which is a common problem with any SSDs. So we'll look at how get by primary key works in Aerospike. So what happens, like we saw earlier, Aerospike client knows the partition map already. So when you search, when you want to fetch a record by ID, let's say 11, it will calculate the primary key hash and the partition ID based on that. And it will know that the data is on node 1, the master copy. So it will directly go to the node 1. It doesn't even have to go to the other nodes. That is what the one hop to data is. It goes to node 1 and it does a lookup in the primary index, which is a arbitrary, and it's in memory. So in memory lookups are very fast. It will have references to data on the flash, right? And then it will read the data from flash and would return it. So exactly one IO operation here, or exactly one read from the flash. That is the reason Aerospike is very fast when it comes to getting data based on the key. Here is an example of the how the API looks like, very simple, right? Let's look at secondary index, because primary index, it cannot serve all the purposes, right? Oftentimes you would want to search on different attributes. So for that, you can use a secondary index. Secondary index is again stored in memory alongside primary index. So each and every node will have its own index, right? So secondary index on node 1 will have data from the node 1 only. So they are very local. They will not have any cross references, right? And so on and so forth. So whenever you do a secondary index query, the request will be sent to all the nodes, and each and every node will do a lookup in memory. Secondary indexes are basically B plus trees in Aerospike. So they will do a lookup, get the data, collect the data from all the nodes, and that and then it would be returned, right? So secondary indexes are also pretty fast. Not as fast as primary index, but still very fast. So some sample API calls for secondary index. You can also provide, you can do range kind of queries as well on secondary index, which is not possible on a primary index, right? This is another thing which we had done is batch reads. I think Unmesh has also written a good article about it. You can go and read about it. So batch reads, basically what it does is it allows you to make batch calls so that you can save on IO operations, right? Or round trips. So Aerospike allows you to do that. You can make call with multiple primary keys, right? And it would be able to return you the data. It returns the data exactly in the same order in which the keys are sent. There is a mistake here. It should be a list of person, right? So you just have to make sure that you have enough memory in the application, and huge batch sizes can create bottlenecks. if your payload sizes are also huge, right? So just keep that in mind. And there is something called as filter expressions, which is also there, right? The problem with secondary index is Aerospike doesn't allow you to query on multiple secondary indexes, and there is a reason for that. Let's say you want to query on city and name, right? You want to get all the, let's say, give me all the Nilesh who are staying in Pune. You would have to query on two indexes here, right? So which means already it is going to all three nodes, plus it has to scan multiple indexes, right? And in cases where you have or kind of predicates or and kind of predicates, it becomes difficult because then you will have to refer data from the other node, which actually goes against the architecture and it becomes extremely challenging. That is why Aerospike took a decision to not do that, right? So all the it doesn't allow you to query on multiple secondary indexes. That's a limitation, but you would want that to happen, right, in usual applications. With us also, there was a use case of that. So it provides you something called as filter expressions. So what you can do is you can use filter expression in combination with a secondary index. Secondary index, it will get data based on secondary index and it will utilize whatever the available RAM is there in that node to filter out the records in memory, right? And then it will gather records from all the nodes. That's how the filter expression works. So if you are using write index, meaning the index which is able to return you lesser data set, so that memory consumption is less and in-memory filtering is also faster. I think that pattern is much preferred over using secondary index, right? So we ended up using this pattern as well a lot. This is a different pattern which is not provided by Aerospike, but we ended up using it, which is mapper table pattern, right? So you can basically query on secondary index as well, but secondary indexes are not as fast as a primary index. So what we found is primary indexes 99 percentile was comparable with secondary indexes 95th kind of a percentile. So that kind of a difference was there, meaning primary indexes were much more consistent than secondary indexes, right? So this pattern is very similar to materialized views in Cassandra, right? It is a little different. So what basically, let's say if you have a table called as person, the primary key is your ID. And if you want to do a query based on the city, instead of creating an index on this bin, what you can do is you can create another set called as city to person IDs, which would hold the city, which is a primary key. There is a mistake here. This should be Mumbai. So city would be the primary key here, and it would have a map of or the list of person IDs for the given city, right? Um, because Aerospike supports list and map kind of data types, you could do this. So this is how the code looks like. Get all the records for the given city or get all the IDs for the given city. And for each primary ID, I can get the data directly from the person set using a batch read, which effectively becomes much faster than using a secondary index is what we have observed. So, but you have to be careful with this pattern because this can mean more maintenance or maintainability is basically reduced. So hybrid storage, these are the hybrid storage options which are provided by Aerospike. We used the recommended one, which is data on flash and index in DRAM. Typically, this is what is recommended. There are other options based on what kind of a data you have, right? So what makes Aerospike fast? Like we saw, hybrid memory architecture, where data is on flash, indexes are in memory, meaning both reads and write are very fast. Because when it comes to writes, doing any operation on, let's say, B plus tree or red black tree in memory would be much faster than doing it on flash, right? So writes are also very fast when it comes to the Aerospike. Like we saw earlier, smart client, which means exact hop to the data, one hop to the data. There are no multiple hops. That also makes it very fast. It is written in C, unlike other databases like Cassandra, which is written in Java, and it shows in its performance when the volume goes up, right? It's written in C, so it is very optimized. Also, they have written their own layer of persistence, bypassing the operating system file system to take the full advantage of flash storages. And like I said, Aerospike is written from scratch. Right from the beginning, they wanted to create a database specifically for flash storages. So it is way more optimized for flash storages, right? And parallel DRAM index. One thing I forgot to tell, these indexes, primary indexes, it basically contains multiple red black trees in memory so that you can do the lookups in parallel and speed the reads. These are some of the benchmarks compared with Cassandra. This is the throughput. This one is the latency, right? You can see the difference. These test results are readily available. In one of the tests which was done on Google Cloud, the Google engineers, what they found is to serve 1 million or 10 million requests per second, it takes up to 300 Cassandra nodes, whereas you can achieve the same thing in 50 Aerospike nodes. So since it is very fast, low latency, and the response time is very fast, the total cost of ownership also goes down, right? If you compare 50 nodes with 300, just imagine the amount of cost which would be saved. This is a comparison of Couchbase, which is again another very good NoSQL database. It is also in-memory database. It basically caches data in memory. It works a little differently than Aerospike. So this test was done keeping in mind that more than 90% of the cache hit rate would be there on Couchbase side, because that's the most optimized thing for Couchbase. Still, you can see the response time and the latency is very consistent for Aerospike compared to Couchbase, where you can see a lot of spikes, right? And finally, this is what our API response time looks in production. So if you see, this is a data over 15 days, 4.56 milliseconds mean response time. Even if you calculate 95th, 98th percentile, it would still be less than 10 milliseconds, right? And very consistent response time as well. So yeah, this is about our response time. This is Aerospike real-time data platform. In nutshell, it supports various data models, not just key value. Key value is basically its foundational data model, and it builds on top of that. So it also supports document. You can use it as a document database. Basically, it is achieved using APIs. Storage still remains, storage is still the key value storage. It also supports SQL using Trino. So Trino is a distributed SQL engine which you can use to query Aerospike. That's how you can utilize Aerospike as SQL model. It also provides graph and time series models, again using APIs, right? These are the hybrid memory options which are supported. Some interesting things, Trino, like I talked, you would be able to fire SQL queries on Aerospike using Trino, which we also ended up using because we had, because there is a limitation of Aerospike, how much of analytics queries you can run, right? You can't do that. So you will have to go for something like Trino. And if you want to use Spark, there are connectors for Spark available too. There are a lot of other connectors available for doing change data capture, meaning if you want to send data to stream data to Kafka, Pulsar, or any other messaging broker or the messaging queue, you would be able to do that using connectors. Right, the Aerospike is basically, it comes in two flavors. It has got standard edition and an enterprise edition. Standard edition is the open source one. But there are certain limitations, like you can do XDR, which is cross data center replication in enterprise edition, which is not there in open source, right? Strong consistency, encryption at rest, and a lot of other connectors do come in enterprise edition only. But in the end, even if you go for enterprise edition, your total cost of ownership still is very less because it will end up using less amount of hardware. Plus, it takes little less maintenance than other databases like Cassandra because all the cluster is auto balancing, it auto heals, data is very much balanced, right? So it means less maintenance overhead as well. So total cost of ownership is much lesser, even if you go for an enterprise edition. These are some of the use cases for other use cases for Aerospike. Like you can use it as a replacement of a cache like Redis. If you want to keep both data and index in DRAM, that is also possible. You can use it for recommendation engine to query things in real time or to ingest data in real time, right? Because it also provides low latency writes. Same for fraud detection, profile personalization we saw, right? Real-time analytics, again, very fast, and you would be able to leverage all those connectors to do it. You can use it also for online gaming. A lot of startups in India are already using Aerospike. Like I can throw a lot of names, like Flipkart is using it for e-commerce. Big Basket is using it for e-commerce. Dream 11 is using it for gaming platforms. PhonePay is using it for transactions. Mm, what is a lot of other names which are already using leveraging Aerospike a lot. So these are some of the learnings based on from our project, right? So understand the speed versus pace trade-off. Um, you'll have to consistently think about it because many times you'll be able to achieve one or the other. You'll have to understand the data volumes very well to be able to take these decisions, right? Establish query patterns and other design patterns early on. Some of these decisions we took very early on and that definitely helped us. Capacity planning is also very important, right? Understand how much data volume you have got, what is the record size, what would be the index size, how many indexes you would want to create, because you cannot fit in a lot of indexes in memory. There is a limitation of DRAM, right? It would be limited, right? It would be like 8 gigs or 32 gigs of DRAM. You cannot fit in a lot of indexes. Whereas you can add a lot of nodes, parallel nodes, and data, since it is distributed and auto balanced, that way you would be able to scale it. But still there is a limitation, right? So you'll have to decide whether you want to use a lot of secondary indexes or you want to go for primary index or mapper table kind of an approach and do that trade-off of space versus speed, right? Um, use of concurrency needs CPU tuning, so just keep this in mind, especially when you are deploying on Kubernetes clusters. There would be a lot of pitfalls based on how you set your request limits and how JVM interprets those numbers. The concurrency level is impacted because of it, so just keep that in mind. Heap tuning is also very important for predictable performance. Um, yeah, and also do continuous performance testing because we were doing performance testing right from the first iteration itself. Each and every commit we were doing performance tests each and every day, right? Meaning we had consistent eye on how it is performing, and whenever we used to add a new index or a new search parameter, or there was a growth in the volume of the data or the number of IO calls, all of that we were able to figure out based on the performance testing. And don't underestimate small performance optimizations. They can make a huge difference. And I think right from the day one, since we did those optimizations, even we were surprised with the kind of result we achieved in production. So that's all. Thank you. Any questions? So it offers you a lot of deployment topologies, right? You can go for Kubernetes cluster or you can set up VMs I think when we did set up Aerospike cluster, that was the time when we had a chip shortage. So a lot of less hardware was available. In that process, we ended up going for virtual machines. So our cluster is set up on VMs. However, it also provides you to do setup using Kubernetes operators, Helm charts, and that option is also available. You can set it up on cloud as well, like AWS, GCP. Ours was on-prem. Yeah, yeah, yeah. Yeah. Oh, go ahead, Nilesh. Hmm. Yeah, 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 yeah. This one, right? Hmm. Huh. Hmm. Hmm. It doesn't. That's a beauty. So without impacting any reads and writes, it will do the auto balancing. So it is very transparent for the clients, right? So it will start copying the data first without deleting the data from the older nodes. Once the newer node has caught up to the speed and has updated its partition map, that's when the client would see the updated partition map, right? So so partition maps, so Aerospike will make sure that you would always get the latest copy of the data. I don't know the details of the internal, but yeah, yes, yeah, yeah. So sure, sure, yeah. So you can't get all three. Like no SQL database would be able to provide all three, right? And partition tolerance. So it shines in both. You can set it up as AP or you can set it up as P, right? It doesn't matter. It shines in both because it provides strong consistency. But as soon as you get a strong consistency, availability is compromised a little bit. That is also when you face very bad situation, rainy day kind of a situation. That's when you would lose the data when you set it up in AP kind of a mode or in CP mode. Availability would be impacted for the writes. For reads, you can still get the data, right? So it is similar to other NoSQL databases. Good question. So see, under the line, the storage is still key value, right? So even if you use it as a document database, the data is still going to be stored as a key value. All the operations on document are handled using API, right? Because it supports map and list as a collection, as a first class data type. You can pretty much do anything on those using those collections. So basically it allows you to fire JSON path kind of queries on the document at the client on the client side. On the server side, it is still key value. So even if you do version upgrades, I hope you're talking about server version upgrades. Uh, uh, uh. Okay, so first thing, there is no schema, right, when it comes to NoSQL database. So there are no migrations as such. The only place where you would need migration, or at least we felt need for migration, was indexes, right? Because index creation, it was kind of a manual activity. We were losing track of what all indexes are created, needs to be created. That is the only place where you would need migration. Otherwise, since there is no schema at all, you don't need any kind of a migration. Hmm. Yeah, yeah, yeah. So we did manage to model them using lists and maps again. same stuff. So many to many can be converted into one to many using list and map, right? So mm-hmm. Graph. Yeah, I mean, you could have chosen graph as well. Yeah, graph database would also shine there, but there is no limitation here. You can achieve the same because you can also do indexing on lists and maps. It allows you to do that. It allows you to. Hmm. Okay. Got it. Got it. So in the context of customer 360 profile, yeah, I agree. Yeah. So we had also thought about it. Even I was exploring graph database for this use case, but I didn't get a lot of insights on that. I have heard a lot of people using graph databases for such kind of use case. But yeah, I mean, you could achieve this using RDBMS as well, NoSQL or graph as well. I think we decided to go with NoSQL. So. That is not a first class model, I would say. And I don't think so. We had time to think about, use Aerospike and then use graph database. In Aerospike, we could have then chosen a graph database in the first place, right? So I would say these data models, they would serve your need if you are in a need of a graph database while you are having a NoSQL database, right? Hmm, hmm, hmm. Mm, 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 mm. Yeah, 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 yeah. Yeah, I mean, very true. Like, in fact, many times I used to model these things using graph only to understand better. So that clearly means graph database could be a better suit suited for this kind of use case. But yeah, I think when I tried to explore graph database, I didn't get a lot of insights or experiences around how did it go when it comes to setting up something like this. So then basically we gave up on the graph database. Yeah, that is very important. So that's the first thing you should do, understand what all queries you want to do, right? That was the first thing we did. We did a POC and made sure that, okay, Aerospike is able to suffice our need. Otherwise, it's of no use. Migration of data from Postgres to Aerospike, you mean? So it provides you data loader utilities which allow you to load data from CSVs. So basically you can dump data from Postgres in CSVs and use ACE loader to load data from CSV. So possible, yeah. No, no. So generally people will not go for such a database when it comes to storing, let's say, accounts or balance, right? They need ACID compliance database. I don't think so. Aerospike is ACID compliant, so for sure, no. Yeah. Mm. So there was another relational database, Legacy, from where we got the data using change data capture. In the long term, the plan would be to redo all of this. So it's kind of in a journey, right? So this is the first step. Next step could be to get rid of that RDBMS altogether. Yes, yes. That would be my next talk. uh, question or right. So performance test is the only way you can figure out whether it is predictable or not, right? So we used to, yeah, yeah. So I mean, all of that you will have to factor in your load tests and PT tests, right? Like you can do. So we used to our general test would be with the expected throughput on production. Oftentimes we also did load tests randomly with 5 times of the load, right? So you'll have to do such kind of tests to understand how it is scaling up or how it is reacting, and look at the results and you would get your answers. Same for using primary index versus secondary index versus other patterns. Oftentimes we said, okay, we were confused about, okay, what to use, right? I mean, everybody would have a different opinion. We would say, okay, let's go ahead with primary index approach for now, or maybe let's go ahead with a secondary index approach. We'll see how the performance looks, and then we'll do a course correction. We'll fall back to some other query pattern if the results are not great. And many times you have to decide it based on the volume of the data. For example, I can't use a secondary index on something like city. It's not going to perform so great, right? Whereas I can use a secondary index on a bin which is which has got a relatively high cardinality, so that my filtering happens efficiently, right? So all of that you'll have to take into consideration when you are designing it, right? Also, while using mapper table kind of approaches, oftentimes it becomes very complex to maintain it, right? So we had mapper tables where values were hash maps, and there were multiple keys. Doing writes and deletes while maintaining these data structures becomes little tedious. Also, maintaining consistency between primary table and these mapper tables is another challenge. So you'll have to decide like how complex is it to maintain. If it is getting too complex, forget about it. Will compromise on the performance. What we made sure is the primary use cases we had, where we would be receiving the most hits, we made sure that it is the most performant and followed the best route to the data. First time. Yeah. So yeah, like any other NoSQL database, we knew that there would be limitations, right, in terms of querying on multiple beans, range queries, indexes. So with that apprehension, we did a lot of POCs early in the project to validate our understanding, and we actually found that it is going to help. Yeah. So MongoDB again, when it comes to performance, I would say it doesn't shine very well because first thing, it is not written keeping Flash as a primary storage in mind, right? There are benchmarks with Mongo as well. I haven't shown here, but there are some benchmarks there too. The sharding mechanism of Mongo is also a little weird, I would say. Also, it uses query router to route the queries, right? So I don't think so MongoDB shines when it comes to performance. It definitely shines when it comes to managing heterogeneous data, right? But even Cassandra would be able to outperform Mongo, I think. Not sure, haven't done hands-on Mongo in a long time, but yeah, there are performance benchmarks with Mongo as well. So no NoSQL database comes close to Aerospike as of now in terms of performance. Also, Aerospike is the first database which supports Optane storage, which is a relatively new kind of a storage, extremely fast, very expensive. But Aerospike is the very first database to support that kind of a storage. We are using NVMe. NVMe and DRAM. Yeah. With Optane, the performance would be much higher than this. Sorry, once again. Uh, So we were also looking at Redis database. It's very commonly used cache, right? So basically, first thing everyone will think about when it comes to optimization, let's dump in a cache and everything will become fast. So, but Redis is not, it doesn't provide a lot of things like it's, first thing, it is single threaded. It is, recently it has become distributed. It wasn't earlier. Plus it has recently started supporting persistent storages, or I would say Flash and all. Persistence is second thought when it comes to Redis. It was always an in-memory cache, right? Recently, the way they have implemented persistence is also a little weird, using AOFs and all. Plus, it doesn't provide strong consistency. So it doesn't fit a lot of use cases. It is good for a cache, but using it as a primary database, people say it can be used as a primary database. Mostly Redis people would say that, but still it is far from that, I would say. So yeah, coming back to your original question. So we also were exploring Redis, right? And Aerospike also. And we did POC on Aerospike to make sure that at least it would work. Otherwise, we were going to rule it out and maybe fall back on some other database. I think it would have been RDBMS then. So we would have compared it with the RDBMS. And if the performance was not so great, if it was like, let's say 100 millisecond versus 70, 80 millisecond, RDBMS would have been easier choice, because then you at least get a flexibility to query, right? When it comes to RDBMS. Yeah. Cool. Great. Thanks a lot, Fox, for coming. Yeah, I know. Their loss.
Okay. One of the days where we struggled with everything.